M&M World, there are 2 super deals for buying your favorite candy in bulk. Option 1, a 12-pound bag costs $24. Or option 2, a 6-pound bag costs $18. Which would you choose and why? So I asked this exact question to Benny and Lucas, and I'm very excited to share they had 2 different ideas, which as a math educator, you kind of always cross your fingers that this happens because so many concepts are talked about, ideas are shared, and it opens the eyes that there are multiple ways of looking at math and using the properties of math. So without further ado, here are Benny and Lucas, but I think Benny is going to share his first. All right, talk it out, guys.
I think we should figure out how much money is in each pound so that we can figure out how much, what would be better to buy. And I think that we should compare them and see which one is a better deal and which one's more, and it's not good. Can we separate and do?
Sure, but let's do one at a time then so that and while you're solving, if you want to do it in a different way, make sure you're explaining what you're doing with everything you pick up, okay? Okay, go ahead.
You want to go first, Bennett? Yeah.
So remember, explain to us, what does that represent?
It represents how much money costs 12 pounds.
So what are you thinking, sweetie?
So we have the factors here, and there's 6 2s and 1 12, and since there's 24, I'm going to use 2 to get all the way up to represent 1 12, and the 2 is how much money is in 1 pound of this.
1 12?
Or 2 12s.
I see. So you're using the factors of 12 to help you with 24? Okay. How do you know you can use the factors of 12 to help you with 24?
Because 2 12s equals 24.
Nice. So what did you find?
I found that there's $2 and 1 pound.
For the option 1?
Option 1.
Okay. So we want to move on to option 2? Just leave that right there. Move on to option 2.
18 represents how much money is in a 6-pound bag.
Okay. Now what are you thinking?
3.
What about it?
3 groups of 6 make 18 instead of 2 groups of 6 that make 12.
Okay.
So 3 would be how much money is in 1 pound.
Okay. Let's see. How many is in each of the 6 pounds? Cool. So you found that option 2 has
$3 in each pound.
Okay, and option 1 is
$2 in each pound.
So based on
you can also see it because there's 12 2s and 6 3s.
Right. Good job. Good use of factoring. So which option would you choose and why?
This one.
Why?
Because it's cheaper and it gives me less candy because my parents don't let me eat a bunch of candy at once.
You think you'd just be spending less money?
Yeah.
And you'd still be getting a lot of candy? Okay. Nice. Okay. So interesting reasoning, right? So his strategy, basically, if I were to sum it up, is he wanted to find the cost per pound for each of the options. So he thought, okay, if it's a 12-pound bag costs $24 and 2 times 12 is 24, I know that each pound costs $2 for option 1. Then he built option 2, trying to find the cost per pound, and honestly used some crazy connections through there. like, oh, I'm going to use the relationship between 6 to 12. And if it takes this many 6 for this one, it's going to take this many 6s for this one. So I know 3 is the factor I'm looking for. I was like, okay, that's awesome. Okay. Do y'all ever have this happen with your kids? You're like, how did you get that? Oh, wow. Okay. I get it. Like, that's amazing. So he said 18, got around to 3 times 6 is 18. So he put up his 3. And he said, okay, for option 2, it's $3 a pound. But he was adamant, I'm still going to choose this one. Did y'all hear his reasoning? I know he talks very, very quiet, but did you hear his reasoning? It's like, well, if I'm not going to get to eat all this candy, like there's 0 way I'm going to be allowed to eat 12 pounds of candy, and I had to choose one of these options, I guess I'm going to choose option 2. Because then at least I spend less money. I was like, okay, that sounds good. That's so awesome. Amy, you said great way to connect unit price and how to watch labels. Celestial, you said in the grocery store discussing unit prices. Absolutely. Oh, from your mama's lesson when she took you to the grocery store? Yes. Melissa, you say my students will require so much prompting to do this problem, but the visuals, especially the way Bennett is doing it, would be so helpful for them to see it with the stackers. And I'm so glad you said this, because I love to just bring up this point. And we know how to guide our students, right? Sometimes when you read, so let's talk about reading. Do you ever expose your students to texts that maybe are above their reading level by reading it to them? And then we all discuss it together, right? That's a technique in reading education. I encourage us to do this, like Melissa is saying, with problem solving in math. We all get to be a detective together. If it's something that you, maybe even this problem right here, maybe you're a 2nd grade teacher and you guys haven't talked about factoring. You haven't even really talked about multiplication. This is something you could do together in a circle. Like, how are we going to figure this out together? Let's build it. Let's try some different things and go through it, the motions together to solve it. That's an awesome way to show your kids, like, hey, it's okay if you don't automatically know this. Like, let's talk it through. Let's just be curious about this problem. I love that, Melissa. Tracy, you say listening to their reasoning after the final answer is so important. It's so important to have them explain how they got the problem. I agree. Because number one, I think most of us, I'll speak for myself, I definitely assumed everybody to, after figuring out all the kids, to choose option 1. I didn't even think about this. Option 2, like, well, I can't eat that much, so I don't need to be spending that much money. And I loved that reasoning. I'm like, that's so true. We can all learn a lesson from that. Lolita, you say you love this entire concept. This is a great connection. I love how that math stackers can be used to target upper grades. So I want to move on because Lucas had a different way of seeing this problem, and I want to make sure that we share and talk about this. So let's go to Lucas's, we'll come back to this, Lucas's idea of how he solved this problem, because it's different than Benny's, and I love it. Okay, you had a different idea. Mm-hmm. Yeah, you can knock that over, Bennett, over there. Oh, nice. Okay, go ahead, Lucas. Let's hear your idea.
My idea was that I wanted to know what happens if we added we added 2 option 2s together, mm-hmm. and see if it was better or worse.
Why would you want to add 2 option 2s together? What gives you that idea?
Because option 2 is 6 pounds and option 1 is 12. And I wanted to see if I added them both together, see if the pounds are the same and the amount of money was the same.
Okay, so you're going to double option 2 to get it to the same poundage, I guess, as option 1, and you're going to see how much it costs. Okay, cool.
So, just like that.
So wait, why are you doing that? Why are you putting 2 10s together and 2 8s together?
Because this is the 20. Because like if you add 2, It's
So what
36.
What number are you trying to double? I think you're skipping that
I'm
for
trying
us.
to double option 2.
So, but what number in option 2? What are you?
18. The amount of money. 18.
Okay, can you show us 2 18s first? I think you're skipping that.
Okay.
There you go. Just because you're jumping ahead in your mind, which I love,
And
but it's
then-
hard to follow. Okay.
And then next we have to add them.
Okay.
So we just put this here because I don't want to put it in one big stack so
Okay.
it doesn't fall.
Sure.
And then next, if we put it like this, it just is on the ground now. So now it's 36, which is way more than option 1
How'd you get 36?
because I added 2 18s.
Which is? Oh, 2 18s. I see. 36. Excellent. And you say that's way more than option 1
So I
for
think
12
option-
pounds? Okay.
Yeah, so I think option 1 is better
Why?
because it's cheaper.
It's cheaper. You get a lot of candy. So you think for you, it's a better deal just because it's less
Yeah.
for the 12 pounds.
Even though it's the same amount of Skittles, probably same pound.
M&M's?
M&M's. it's still option 2 is still more expensive.
Okay. Excellent. I like that you both solved it in a different way. I also like that you both chose a different option for different reasons, even though you kind of found the same results, didn't you? You found that option 1 is less per pound, right? And option 2 is just more expensive. However, Bennett, you didn't want to waste money that you knew you wouldn't be able to eat, right? Nice. All right. Thank you very much, guys. Give each other a high five. Oh, yeah. Bye. Thank you.
Bye.
Okay. So did you see what Lucas did? I loved his idea. He said, okay, I see a connection, right? In option 2, we're talking about 6 pounds of candy. And in option 1, we're talking about 12 pounds of candy. So focusing on those pounds. He's like, well, I can just double option 2 to get an equivalent number of, if it's consistent, right? Each pound, I can double the poundage. So if I multiply 6 times 2, I get 12. So I have those 12 pounds in both, but then I need to double the cost that was for 6 pounds, which is 18. So he doubled 18 and said 36. 36 is definitely more than 24. So, I mean, at this, from his comparison, when he said like there's the same amount of pounds, when he scaled it, it was the same amount of poundage, but way more cost for the option 2. So in his, he's like, oh, I'm going for option 1. Maybe if I wonder if many kids will be like, I'll just sell it. We got some entrepreneurs in the class, maybe. Marcia, you said, I love this. So students will not get to this level of understanding from the beginning. Exploring and using the math stackers to represent number relationships help build to this level. I love that. I agree too. That was my experience as well. Stephanie, you said, brilliant, Lucas. Love the reasoning. I also say that, Stephanie. I was so impressed. Amy, you said you have a small group of 3 kids at very different levels of understanding and skill. Using math stackers has helped you differentiate your lessons so much easier. I love it. Holly, you say this is the problem with standardized testing, though. It doesn't allow kids to justify their answers and puts them all in the same box. Yeah, that's true. And Sydney, you're agreeing. But I love these types of opportunities for your students, right? We're going to do what we can to give them the space and the opportunity to explain their thinking to us. And then we know how to, like we've talked about, lower the floor or raise the ceiling, which we're going to get to in just a second. So be thinking, how can we do that? What kind of questions can we ask in this situation for our students? The math concepts that Benny and Lucas used. So of course we have multiplication, division. We have factors and multiples. They talked about that a lot. I kind of want to add on here scaling, because Bennett scaled in his solution. And then I put in here critical decision making, because this is what math is all about in our daily lives. We use math to analyze information, see everything that is put before us, and then we make the best decision for us. And I love that these guys took the opportunity to do that. Okay, what questions are we going to ask? We've been talking about factors, multiples, multiplication, division, cost per pound. We've talked about a lot here. How can we lower the floor? Thomas, you say lower those numbers. Excellent. Exactly. Make the numbers that your kiddos are working on, right? Also, all these problems, you can change the numbers in it. There's nothing magical about it. Is there time to compare fractions that don't have equal denominators? Christine, if you're talking about tonight in the webinar, we do not. However, there are a lot of levels and videos in Math Stackers U that cover that. And actually it covers how to get your kiddos to that reasoning. I can show you in just a second in Math Stackers U. Holly, one student mentioned Skittles. Maybe give him pricing for Skittles too to determine whether they are more or less expensive than M&Ms. Sure. Amy Sue, you say these opportunities to explain knowing their idea can be right, even if different. It allows us to honor the background differences used to figure things out and not have to be right or wrong. I love that. Celestial, you say questioning is so important. Modify the numbers. Absolutely. And then I said, if the decision making is too much, break the problem down into 3 parts, only moving on to the next when they have successfully found the cost per pound for each option. So like, I always said, we can just do this step by step together. It's wherever your students are. Let's look at option 1 and don't even show option 2 yet. This is how much is this a good deal to you? Is $2 a pound? Like you can get on, do research, online. Is this even good? And then move on to option 2 and then talk about the decisions, like, just kind of limit the amount of information that is available all at once. And then let's see, Chrissy, you say you ask your students to explain their thinking and they don't like to give an explanation. They just want to find the answer because it is what they're used to. I like them to explain their thought process and see how they are thinking, especially when they get the wrong answer. Absolutely, because it gives us a clue into what they're doing. And one thing that I love about Math Stackers or blocks is I can see if they start doing something, that's my first clue. Like, okay, these are the thoughts they're having in their head. Especially if you have any students who maybe struggle with verbal communication or written, right? Either way, those are the traditional ways for kids to show their thinking. I can see physically as they move stuff around what they're doing, and I can ask questions accordingly. If we want to raise the ceiling, how can we do that? Lolita, you say you can add in half pounds. Absolutely. I put, and of course, I wonder if Thomas is about to put this, but we can raise those values, right? We can make the numbers bigger, or maybe we're working on larger quantities. And then I said we could find the ratio that represents how much more costly is option 2. Ooh, that'd be raising it, right? By how much more is it costly? Give me a ratio. Let's see. Amy, you say it's a great way to acknowledge their thinking and celebrate it. Oh, Sydney, you say let's raise the ceiling by adding a 3rd option. I like that. Marsha, increase the number of bags for sure. Okay, awesome ideas, everyone. I wanted to make sure I got to show you where to find all of this in Math Stackers U. Okay, so coming into Math Stackers U, we have got here at the top our guest expert webinars. This is where we bring in awesome educators who are using Math Stackers in their classrooms with their kiddos, and they share the strategies that they use, and they have downloads, all that kind of stuff. The Build Math Thinkers webinar series. I know some of you are asking about fractions. This is a great overview that I do of the discovery guide level. So we have addition, subtraction, multiplication, fractions. Eventually I'll do adding fractions 1, but it all builds on one another. So if you are just new and starting with your Math Stackers learning system, there's suggestions in your discovery guide. So for example, for multiplication, you need to know some concepts in addition, because we're going to come back to those, like the commutative property. Anyway, this is a great overview that shows kind of how to use your discovery guide to build on that reasoning, get into that fractions reasoning. And then here's our exclusive Math Stackers U webinar, which you're in one right now. So I had a get inline graphing. This one is all about graphing. This is particularly interesting for you guys. This is an hour and a half long of content. And all these videos, if you click, as long as it's not for pre-K, because pre-Kers typically have not learned to read yet, so station cards aren't as helpful. But if you click on the attachments and come down here, there are loads of resources that you can download. I'm talking even like specific grid paper for your mini Math Stackers mini magnets, foldable station cards, all sorts of stuff. We love making things to make your life easier. And then right here, so here's our problem solving one that I was talking about at the beginning of our session today for K2. If you missed that, go log into Math Stackers U and you can watch that one in its entirety. And then I will load this today or tomorrow, the one that we're in right now. I'll edit it and put it in here along with the station cards for the three problems that we did, because this is a Math Stackers U exclusive. So all of these downloads are exclusive to you. If you have a Math Stackers learning system, you have access to Math Stackers U. So get in there and take advantage of all of this. Here's our pre-K content right here. And then this is the discovery guide videos. Addition, subtraction is Bennett and Lucas when they were younger. They were only 6 in these videos. And the reasoning was building and building and building. Each of them has a station card. And then for multiplication, fractions, and adding fractions, we have Eli and Nick. And they're same thing. We started here with the first level of multiplication, went through everything, then hit fractions, went through everything, then it added fractions and everything. And you can see their reasoning build. And here towards the bottom, we have our problem solving. So this is what we talked about today. So there's our grades K through 2nd. And then we have our 3rd through 5th. So that's where you can find those. You can click on them. The station card will be on there. And then we have some awesome pattern challenges. And this is where we'll add some more of our great extension activities that we have coming up. Okay, so I'm going to get this slideshow back up. There we go. That is where you find all of them. There is a plethora of information in Math Stackers U that you have on-demand access to when you invest in a Math Stackers learning system. And that, just to remind you, you have access to that for the lifetime that we're a company. We're just going to keep it up for you because we want you to be equipped to use your Math Stackers every day to build math thinking. So if there are some of you here that do not have a learning system yet, we want to make sure you know mathstackers.com is the only place that you can get an official Math Stackers products. And the learning system, it's the one with the blocks and the resources. It comes with a membership to Math Stackers U. So make sure to tell your admin to invest in one of these for you, because you're going to be just equipped beyond measure to build math thinkers in your classroom for years and years and years and years to come, because we make these babies to last, right? We have some teachers who have used their same set for 10 years now, which is awesome.